because the point is imaginary and the limit is approaching this imaginary point. So that's what you should have gotten, was that it does not exist on this one. All right, move on to the next one. Split across the board. Majority of the people got this one right though, but it is 2 over 5, and it comes down to this definition of this limit right here, right? Let's take a look at this problem. Let's take a look at this problem here, written down. So, wow, that's gigantic. So when you're looking at this problem, right, you guys need to remember, when you're looking at the limit as x goes towards infinity or it goes towards negative infinity of a function, right, that's basically the definition of a horizontal asymptote. That's asking if there's any horizontal asymptotes for this one. One way you can do that is, if you know that it's looking for a horizontal asymptote, you can write down the rules for horizontal asymptotes, right? If you have some function a times x to the m over b times x to the n, and you have some other stuff following that, you really want to focus on the degree of the numerator and the degree of the denominator, right? This m and this n. If the degrees of the numerator is equal to the degree of the denominator, then you're going to have a horizontal asymptote at y equals to the lead coefficients divided by each other. So a over b, in this case, 2 over 5. And that's what the limit of this thing is approaching. It's approaching 2 over 5. All right, that's one way of doing it. If you're looking at rational functions, you can remember the rules for horizontal asymptotes and just set y equal to those rules. And that's one of them, if m is equal to n. The other one is, by the way, n if m is less than n. If the numerator is smaller than the denominator, then you'll have a horizontal asymptote every single time when y is equal to 0. Okay? When y is equal to 0. And last but not least is if m is greater than n, then you have, right, no horizontal asymptotes, right? That thing's going to go off towards infinity or negative infinity, and that's what you need to work on to figure out, is it positive infinity or negative infinity? And that's only if the degree of the numerator is greater than the degree of the denominator. Okay? And, by the way, at this point, while I'm going over this, if you have questions, please type it in the chat. I don't know if you have questions or not, because I can't read your minds. So type it out. Don't hesitate. This is the time, by the way, where you need to ask questions if you aren't getting it still, right? This is our review, and please don't hesitate to ask. You probably aren't the only one who might have a question on this question that we're working on. Okay, so please ask if you have any questions. And another way that you could do this, by the way, as it goes off towards infinity, is instead of just looking at degrees and comparing them and then going back to pre-calc and practicing to look at, oh, they're the same degree, another shortcut that you can do, or not shortcut, another trick that you can do is, whenever you're dealing with the limit as x goes towards infinity, there is one technique, and I didn't actually show you guys this technique, but there is one technique when you're dealing with rational functions like this. How do you even know when to plug in the limit value and when not to? Okay. When all else fails, try to plug in the value, right? It never hurts to try to plug it in. And if you plug it in and it gives you something like a specific value, usually most of the time that limit is approaching that, if you're dealing with just a function that is like, simple like this, or simple like the square root function, right? If you're dealing with infinity, you can try plugging in numbers that as it gets larger and larger and see what it approaches as well. Like for this one, I could plug in 100, I could plug in 1,000,000, I could plug in 10 million, and you would actually see that as you plug in those values on the table, you will actually see that it's approaching some decimal, right? And if you plug in 1 billion, that decimal should come out to be like 0.4 in this case. That's another way that you can do it. The third way I'm going to show you is an algebraic way, kind of. And it's a little trick that some people like to use when you start dealing with infinity, right? And usually it works for something that looks like this. So if I took this function, right, which is 2x squared plus 3 over 5x squared plus 7, one trick that people like to do when they're going off towards infinity is to rewrite this function by dividing every single term that you see by the highest degree. So the highest degree I'm hoping you guys see is x squared, right? And it happens in the bottom too, but I don't care about that. I just care about it once, right? And what I'm saying is to rewrite this thing and divide every term you see with that x squared term. So here's what I mean. I can rewrite this as the limit as x goes towards infinity of 2x squared divided by x squared plus 3 divided by x squared all over 5x squared divided by x squared plus 7 divided by x squared. And what I'm essentially doing is I'm not changing the value here of my function of this guy. I'm just dividing every term by the same thing. Therefore, I'm not really changing the value. I'm just rewriting it, okay? And when I do this, right, you'll notice that the x squares here are going to cancel out, and you'll be left with this guy right here, which is the limit as x goes towards infinity of 2 plus 3 over x squared over 5 plus 7 over x squared. And this is like a different method of doing it. And you don't have to do it this way, but some people like this method because now I have this guy right here, right? This limit as x goes towards infinity. And you'll notice these are denominators now. My x's are only in the denominators of these values right here. And as it goes off towards infinity, right, as the limit as x goes towards infinity, this function right here, 3 over x squared, is actually going to approach 0. Because if you can imagine this, right, the denominator has some numbers that are going to really, really big numbers. So it's actually going to be approaching 3 over infinity, or in other words, 3 over, let's say, like a billion. And 3 over a billion is a very, very small number. 3 over a trillion is even smaller than that. And if you can keep imagining larger and larger numbers, it's just going to keep approaching 0. And that, remember, that's the idea of a limit. The limit is not what the actual value is itself. It's what the value is approaching, right? And what that value is approaching, it's approaching 0. And the same can be said here in the denominator. This guy right here is also approaching 0. So we do that little trick, we're able to see that this guy approaches 0 and this guy approaches 0, and we're left with just the 2 and the 5. So the limit as x goes to infinity of this whole function is actually just approaching 2 over 5. And that's the answer for this one. And that's just one way of doing it. You don't have to do it this way. You could do it using your pre-calculus skills or your IM3 skills of calculating horizontal asymptotes, because that's what we define a horizontal asymptote to be. Or you could do it this way, where you just divide everything by the highest degree, and this will always work out. And it actually matches up with these rules. And it's something I suggest that you try practicing. And if if it doesn't make sense, come ask me, and we can do more practice with it. Right? So that's the answer for this one. And if you go towards negative infinity, it actually comes out the same as well. This still approaches 0. I'm pointing at a screen, like you can see what I'm pointing to. But if you go towards negative infinity, this is still going to be approaching 0, but from the negative side, but it's still approaching 0. And the same thing for this one right here. Okay? So hopefully that makes sense. And if not, just try a couple more problems. Just practice these out. And I assigned the Delta Math problems that they have a couple there for you to practice. And they'll use the word big instead, right? And instead of writing the number infinity, they'll just write out the word big. So if you have here 2 plus 3 over a very big number, right, and you do the limit of this, you'll see that this also is, they're going to say that this approaches 0. And yeah, that's just another way of looking at it. You don't have to do them all the same way, right? You can approach these problems as many different ways as you want. Okay, so that was that one. For this one right here, find the limit. And earlier was asking, like, so earlier, if you take a look at this problem, right, and you just try to direct substitute right now, right off the bat, and direct substitute in there, you'll see that in the denominator there, you'll get 8 minus 8, which is something divided by 0, which is a undefined term, right? It's an indeterminate term. We can't actually figure out what is something divided by 0. So let's see another way of approaching this problem. Right? So let's take a look here. And I'm going to go ahead and do this one down here. Yeah, go for it. Let's go down here and take a look at this one. And as I was saying, like, you can try plugging in the value, right? So we can try plugging in z is equal to 8. So I'll get here 8 squared minus 64 over 8 minus 8. And 8 squared is 64, and you get 64 minus 64, which is a 0 in the top, and you get a 0 in the bottom. And this is an indeterminate form. This is something we can't calculate. I don't know what 0 over 0 is, right? And I'm just wondering, did you guys put down, it looks like it's split. Does not exist, and 0. 0 over 0 is not 0. 0 over 0 is indeterminate. Indeterminate. I can't spell. Indeterminate form. And we can't evaluate that. 0 over 0 is unevaluated. You cannot evaluate that. And so some of you guys who went with does not exist, it's true that the function is not defined at that point, but that doesn't necessarily mean the limit is undefined at that point. You need to figure out, is the function approaching a value from both the left-hand side and the right-hand side, right? So if you graph it, you'll actually see that, well, you'll actually see that there's a hole at z equals 8. And another way you can actually do that is just by simply rewriting this, right? You can simply rewrite this and simplify this. The limit as z approaches 8 of, let's say, let's factor this guy out. In the top here, we're going to have z plus 8 and z minus 8 all over z minus 8. And if you were to rewrite this, and you can take a look at this here, at z equals to 8, right, we're not going to have a infinite discontinuity. We're going to have a removable discontinuity. And that removable discontinuity means that the limit is probably going to exist. It's probably going to be approaching something, because at z equals 8, that removable discontinuity just means that there's a hole there, right? And that means that this thing is actually going to be approaching something. And when I take the limit as z approaches 8 of this new approximation, plus 8, I can go ahead and plug that in just to see what does it approach. And it looks like this thing is going to approach 8 plus 8, which is equal to 16. And that's how you do that problem, right? It's approaching the point 16, but the function doesn't exist there at 16, right? And that's how this works. So if you are doing these types of problems and you rewrite this and you can't cancel out the factors, then yes, there is a chance that the limit does not exist. You need to do a further investigation and see, does it go off towards infinity? Do they just split and go to different values? Does one go towards negative infinity and one goes towards positive infinity? And any of those cases are the cases that are there, then you'd say the limit doesn't exist, right? But if you have something where you can remove the discontinuity, where you have like something where it factors and they cancel, if you can cancel them out, then there's a good possibility that there's a hole there that you can just basically see what is it approaching if you remove that hole and just say, well, what is that point that it's approaching it at that x value, or in this case, the z value that we're focused on. Does that make sense, guys? I'm not sure if that's a little bit more clear on the answer for this one. But if not, again, right, just type into the chat. The whole point of today and the whole point of Thursday is to review these topics, right? And if you don't get it, you got to let me know, right? I've had people come in during office hours to ask me questions, and that's how I could tell if there are some people who are struggling and they just don't know, they just didn't want to ask during class. And please, at this point, don't feel like you're slowing down the class if you're asking a question. Really, it made more sense. I'm glad that helped, right? If you have a question, chances are someone else has a question as well. And if you ask it, you'll probably be helping out that other person. So please, don't hesitate to ask when we're going over this stuff, right? You're not slowing down the class. This is for you. And if you're not understanding it, you got to ask it and not care about, oh God, I'm slowing this down for the kids who understand it. If they understand it, that's awesome. Don't worry about them. Worry about you understanding the problem. All right, let's take a look at this one. Woo! Find the limit as x approaches 1 from the positive side. As x approaches 1 from the positive side. Oh. Oop, we'll get that. Let's take a look at this problem. Make that a little bit smaller so we can fit that all onto the screen. So this is a piecewise function. There's 3 functions in total, right? 3 functions in total. This function right here, this function right here. That did not change color. Hello? This. Nothing just wants to work right. This function right here, this function right here, and this function right here. And we're looking at the limit, right, as x approaches 1 from the positive side of a of x, of this function right here. So I'm looking at it as it approaches 1, and that happens to be the focus point right here, right, for all three functions. But I'm looking at it as it approaches 1 from the positive side. And that's going to be this guy right here. And hopefully you guys understand. The reason why it's this guy is because this is for all x values greater than 1. And that's what it means to approach 1 from the positive side. It's approaching from the right side, from the everything bigger than 1. So it's going from 2, 1.5, 1.1, 1.01, 1.001. All those values, by the way, is everything greater than 1. So it's coming from 2, right? It's coming from 2, 1.1, 1.01, 1.001, right? I'm approaching it from this side right here. And I don't really care what the value is at 1. By the way, the value at 1 is going to be -1. The function value is equal to -1 at x equals 1, but I don't care about that. I care about what the limit is approaching as I come from that side. So I can plug in these values and see what I get, or I can just plug it into this function and see what it's approaching from the left-hand side. And it looks like it's going to be approaching the limit as x approaches 1 from the positive side. It's approaching 3 minus 6x. And this right here is just going to be equal to, it looks like it's going to be equal to 3 minus 6 times 1, because I'm just plugging in that value just to see what it gets. And it comes out to be -3. And you could try it. You can plug in the numbers into here and see what it approaches. And I'm pretty sure that you will get, it looks like you'll get like -2.999, right? And this will be -2.99. If I'm just like guessing, then this is probably the values that you should be approaching, and this will be -2.9, right? And that looks like it's approaching -3, and that's why that answer is -3. And you got to get that into your head. When you're calculating the limit, you're not calculating the value at that point of 1. You're calculating what is it approaching at 1. What is the y value approaching, right? As I get closer and closer to 1, what is the y value approaching? And the y value is approaching -3, even though the function itself is -1, right? That's the part that you got to make sure you get over and you understand that, right? I don't care what the function is equal to at that point. I care about what the limit is at that point. And not bad on the does not exist part, right? Because they are approaching different values if I was just looking at the limit as x approaches 1 from both sides. But it's this plus sign that's right here that makes it so that you're only looking at it from a one-sided limit. So it's approaching one number on the positive side, and that one number it approaches is -3. Okay? And again, guys, if you're doing all right, right, hopefully you are okay. And if not, that's okay. We'll talk. You just got to start asking questions about it. So this one was the select all statements that are true. The toughest question there. Ooh, accuracy of 3%. Only 3%. That means only one of you guys got this all correct. The rest of you got partial points. So let's take a look at all statements that are true. I don't know how I'm going to screenshot that to get all of them. Let's do it like this, maybe. Yeah, that works. Let's do it like this. Let's get all of these guys and say which ones are true and which ones are not true. All right, so this one is looking at a graph, right? We're not looking at any algebraic functions. We're not looking at any tables. We're simply just looking at a graph and seeing, is this true or false? If you guys have done the homework for 1.2, this should be fairly simple, or not simple, fairly simple. Was it 1.2? 1.1 or 1.2 had, I think it was 1.1, had homework problems that were very similar to this. And I'm hoping that you guys have attempted it. And if not, go there and attempt it, and you'll see that it's not that crazy of a concept of what we're supposed to be doing. So yeah, I just talked a lot and I just said nothing. So let's take a look here at this part right here. The limit as x approaches -1 from the positive side. So I'm approaching this way, right, from the positive side. So it's coming here from this side, and it looks like it's approaching 1. So I'd say that this one is true. I'm not looking at the limit as it approaches from both sides, right? You guys got to understand these symbols. If it has a plus sign, I'm only approaching it from a one-sided limit, which is from the positive side. Let's look at this next one. The limit as x approaches 0 exists, right? It's not even saying that there's a value for it. It's saying that it exists. So the limit as it approaches 0, since it doesn't say from the plus side or the minus side, I need to do both. I need to approach it from the negative side, and I need to approach it from the positive side. Do you see how the limit there approaches 0 from both sides? Seems to be pointing to the same point. That means that that limit does exist, right? If they were pointing at different points, then I'd say the limit does not exist. So since they point to the same one, they're approaching the same one from the left-hand side and the right-hand side, I'd say that this one does exist. I'd say this is true. Okay? Next one up. The limit as x approaches 1 is equal to 0. So as it approaches 1, it has no sign there after that 1, meaning I need to calculate the limit from the left-hand side and the right-hand side. The left-hand limit looks like it's approaching 1. The right-hand limit looks like it's approaching 0. Since they're approaching different numbers, I would say that that limit not only doesn't equal 0, that limit does not exist. Does not exist. I'd say this one is false. Right? Second part, the limit as x approaches 0 is equal to 1. I'd say this is false as well, because we already looked at it. The limit of this thing is going to be equal to 0, because the function is equal to 1. F of x does equal to 1 at x equals to 0. That is true. The function does equal to 1, but the limit, guys, that's the focus that you guys need to look at. The limit does not equal to 1. The limit as it approaches it is equal to 0. Okay, so that one's false. And last but not least, the limit as x approaches -1 from the negative side does not exist. That is true, because I have nothing to approach from the negative side onto -1. So I can't actually say, what is it approaching from the left-hand side? But I'd say that that one right there is also true, because that limit does not exist. Okay? With that being said, I'm looking at the time. I'm at like 2 minutes left, so I'm gonna actually have to stop here on this part, and we'll go over more on Thursday. But just a heads up, I have assigned this to the class. So as a class, you guys will be able to practice this unlimited times if you want. If you weren't able to join my class, I'll put the link again, and just keep trying. I'm telling you, like, you try to join. If it doesn't work, close it out, try to join again, and it's already been assigned to this period, so you guys can try that. That's the first thing up. Second thing up, I'm gonna end this. Actually, no, I'm just keep going on this recording. So the link is still here in the why am I drawing a blank? On the Canvas page, right? So join my quizzes class. The link is still there. I have in my class right now 34 students. I think there are 35 of you, so I'm just missing one of you guys. So you go ahead and try that later. Second thing, the review is posted now, and this is, and again, this is just for your curve, right? So just for your curve, the review is in there, and it's a bunch of problems from 1 to 53, and you skip multiples of 3. So you do number 1, 2, skip 3, then 4, 5, skip 6. So that's how that works. And then do not do numbers 44, 46, 47, 48, and 50. These are printed on the page. Just make sure you 100% this. And then the other one is a Delta Math assignment. 100% that as well to help you with the curve. And we'll talk more about that next time. But this is the last thing I wanted to show you. I'm compiling a list of videos on my AP College Board. I'm not finished with this yet, but if you want, you can watch a video of someone describing these particular topics. If you're tired of watching the videos of me explain it, you can watch these guys explain it. They actually come up with little shortcuts as well. I'm sorry I rushed everything at the end there, but that's pretty much it, guys. I'm at my time limit, so I'm going to have to say that's it for today. We'll continue with this on Thursday.